Hi, welcome to Regular Chemistry. Today we're going to talk about LOLO diagrams, and today we're just going to deal with the thermal energy changing. So remember that only thermal or phase energy can change at a time. You cannot change both of them at the same time, but only one is able to change at a time. So we're going to go ahead and start with thermal. So the first question says that a beaker of 250 mils of water is placed on a hot plate and heated until 90 degrees. Well, one of the things that's really important is this information up here at the top that says if I have a solid, we're going to use 1 bar, a liquid is 3 bars, and a gas is 10 bars. So that's going to be for my phase energy, okay? Now, we're going to go ahead and first start with our diagrams. So I have 250 mils of water, and it's heated until 90. So think about that for a moment as to what state of matter we're starting with. We're starting with a liquid. So I'm going to go ahead and draw a little wave here for my particle picture. And for my first substance, I'm going to go ahead and, I don't know, I just feel like making 4 particles, okay? And they're in constant random motion, so this is a liquid, so I have 4 particles of a liquid, and I'm heating it until 90 degrees. Now remember, when we did our thermal expansion demo, that if I heat a liquid, it's going to expand slightly. Now it's not going to expand this much, but I am going to go ahead and just kind of like show that it expanded, so I'm just going to kind of show a little, it being a little bit higher. So another wiggly line, but just showing it a little higher. Now, I still have 4 particles, and they're still in the liquid form, and therefore they're still going to be the same distance apart. But the difference is that I've heated it to 90, and therefore I'm going to have a second set of whooshies to indicate that it's actually warmed up a bit. Now, my next thing that I'm going to do here is I want to go ahead and indicate the energy that I have. So the energy that I have, I'm going to indicate first my phase energy. And remember up here, we said as far as phase energy goes, if it's a solid, it's 1, liquid, it's 3, and gas, it's 10. So up here, my energy goes up to 10. So I'm going to have my thermal energy and my phase energy. Thermal energy and my phase energy. So really it's like saying this is the before on the left over here, and then this is the after on the right after I've heated it. So we're going to go ahead and start with our before. For our before, we had a liquid, so therefore the EP is going to be about 3 bars. So I don't know, that looks like about 3 bars right there. At the end, I still have a liquid, and therefore my EP is still going to be 3 bars. But what's different is that my thermal energy is changing. Now, usually for room temp, I like to use 2 bars of energy for room temp, though you can use a different amount of bars. I prefer to use 2 for room temp. So I'm going to go ahead and draw in that I have 2 bars to start. Since I'm heating it up to 90 degrees, I just need to show that I'm heating it up. So it doesn't matter, it's an arbitrary number. I could say, okay, well, if 2 bars was room temp, then I'm going to make this, I don't know, I feel like making this like 1, 2, 3, 4. I'm going to make it 5 bars. Now, I know they should all be the same size. I am terrible at drawing, so therefore they're not all the same size, but know that they are all the same size. So basically what's happened here is I've somehow gained 3 bars of energy, right? So where did that energy come from? Well, what I have to do is over here, I'm going to go ahead and draw myself 3 bars or put the number 3 inside of it to say it's 3 bars of energy coming in. So 3 bars of energy come into this system in order to heat up our liquid, okay? Now, what I'd like you to do is think about this for a minute, and then I want you to try the next one. So pause the video, try the next one, and see how you did. Okay, did you pause the video? If not, pause it now, try this one, and then come back. You could always pause it in between if you're getting stuck. Go ahead and listen for a minute, pause it, and then keep going. Okay, so for this next one, I have a cup of 150 mils of hot coffee, cools as it sits on the table. So I'm going to go ahead and start with my cup of hot coffee, and so it's hot, and it's going to cool. So I'm going to start with 2 whooshies, okay? and it's going to cool, and therefore from that thermal expansion demo, remember, I like to show that it's going to contract just a little bit, and therefore I'm going to go ahead and make it just a little lower. And of course, because it's cooled, I'm going to go ahead and do one whooshy instead of two whooshies here on each of my particles. Now, as far as my ETH and EPH goes, I know that once again I'm starting with a liquid and I'm ending with a liquid. So here's my EP, ET, phase energy, thermal energy. So in the beginning I have 3 bars because I have a liquid. At the end I have 3 bars because I have a liquid. Now as far as my thermal energy goes, I'm starting out hot and it's cooling as it sits on the table. So when it sits on the table, it's eventually going to come to room temp, and I like to use 2 bars for room temp. And then over here, it's hot to begin with. So let's see, whoops. I feel like doing 4 bars. And again, they should be equal in size, but I'm not very good at making those equal in size. So notice there is a difference, okay? The difference is right here. It started out having 2 bars more energy. So where did that energy go? Well, that energy had to leave this system. So when it left this system, that energy left, and therefore now the system only has this amount of total energy because this energy has left the system, okay? So just to clarify, this energy over on the left is the same as this energy here, okay? Therefore, the total energy on the left before equals the total energy on the right at the end. It's just that at the end, this is the energy of the system. This is the energy that's been released to the surroundings. Over here, this is the energy of the system, okay, before it was released. Go ahead and turn the page. The next one we're going to try is not the next question that is asking about the soda pop. You can come back and do that one later. I'd like to do the next one that I'd like to do is the one about the fire on your hand, getting near your hand, I should say. So if you can look at that one, it's 2 more questions from this one. Look at that one now and try that one with the fire near the hand. And then if you get stuck along the way, play, hit pause, keep going, play, hit pause, keep going if you're getting stuck. Otherwise, just try the whole thing while hitting pause, come back and play to see if you did it right. Okay, so we're going to start with actually this second one right down here, okay, that your hand gets near a fire. So if your hand gets near a fire, which would not be a pleasant thing, first off, we're starting out with a hand, and therefore we're going to start out with a solid. So the particles of a solid, remember, are going to be very ordered. Okay, so I'm going to go ahead and use 6 particles here. They're going to be very ordered, and the only kind of motion they're going to have is vibration. Okay, so since they're going to have vibration, I'm going to put the little parentheses-like things on the side to demonstrate that it is a solid and that it is vibrating. If it gets near a fire, then in the end, it's not like your hand has become a liquid or a gas. You still have your hand as being a solid, but now it's been warmed up and therefore the vibrations are a little faster, so I'm going to use 2 sets of parentheses or apostrophes, whatever you want to call them, to show that it is going faster. The next step is to do the EPH or P for phase and the ETH or T for thermal. So we're going to go ahead and set that up. I want my phase energy and my thermal, my phase energy and my thermal. So beforehand, I have a solid, so my thermal is supposed to only be 1 bar. And remember that says that up here at the top, okay? At the end, I still have a solid, and therefore my phase energy is going to be 1 bar. My thermal energy, I'm starting out at room temperature, so I'm going to go ahead and make that 2 bars because I like to start at 2 bars for room temperature, but there's no necessarily wrong answer for this one. And since I'm bringing it near a fire, let's say it is 3 bars, okay? Now, those 3 bars of energy, I have somehow added in this 1 bar of energy here. Therefore, I'm going to go ahead and show that 1 bar of energy is going into this system, okay? So this is my system here before. This is my system after. 1 bar of energy has entered the system in order to make my new system. Okay? If you have any further questions, make sure that you see your teacher for extra help. Thanks.